Hi, everyone. I'm Natalie. I'll be your host for today. And welcome everyone that is joining us live here in this meeting room and everyone online, of course. The following presentation will be by Ruchika from Google, and it will be on the Supercharge FHIR search with large language models. If you have any questions, this is specifically for the live audience, please keep them till the end. We will have a couple of minutes left to answer some of your questions. And for the people online, you can use the Q&A function in Whova. Yeah, the floor is yours, Ruchika.
Hi, everyone. Can you hear me?
Yes, you're sounding very good.
Right. Awesome. So I guess my screen is alive also. That's great. So hi, everyone. Hope the second day at FHIR DevDays in beautiful Amsterdam is going great. I'm Ruchika. I've been working in Google Cloud for the last 4.5 years, helping healthcare companies transform and modernize. My focus is specifically in data analytics and all things healthcare in Google Cloud. Some of the fun projects I've worked include things like using Google Healthcare Natural Language API and Document AI as building blocks to automate processes in healthcare. Another really fun one I worked on was building a Fitbit to fire pipeline at scale, and tons of other things. Well, the topic for today is supercharging FHIR search with large language models. I'm sure everyone has been following the developments with generative AI. In the next few minutes, this is what my plan is. I'm going to talk a little bit about LLM usage with FHIR, some specific use cases that I think are top of mind for many people, double clicking on using LLMs for the purpose of searching FHIR data itself. But I want to set expectations that this is not a presentation of production ready solutions, but more of a summary of the various approaches on how to use LLMs with FHIR data, specifically for search. So since OpenAI made the big reveal recently regarding LLMs, every industry and every company I know is in a massive rush to leverage generative AIs and make it part of their business operations, product offerings, pretty much anything they can. But this slide, however, is a blame slide. The era of generative AI began with Google open sourcing transformer technology in 2017. And since then, it has evolved to what is being used by Bard on Google. I won't get into too many details of the various offerings on Google, but in a nutshell, what Google has is a variety of large language models we're using in tasks such as summarization, Q&A on text, generative tasks to create content, images, code, etc., along with tools to fine-tune and create smaller models that do a given task really well. And that's really great. But along with that, we also have things like application layer tooling to make it really, really easy to consume this LLM technology. These could include things like search engines or conversational infobots, and that's just the beginning. So now machine learning has changed drastically. I'm sure there's a lot of people in the room might agree with me, but machine learning has just changed drastically in less than a year. Last year around this time, I was working with companies, and the approach included things like get a whole lot of data, label it, use a framework of choice, TensorFlow, Keras, whatever. Overall goal being to minimize the loss function. And today the approach has completely, in a way, completely flipped. For example, you can do a lot with very few samples. There's a concept of zero shot, few shot. Basically, pretty much just give a direction to a prompt in LLM, and it can do the job for you. Now, if you can just work with APIs, for example, if you just know how to work with Vertex APIs, for example, on Google, you may not need much more expertise, and you could leverage LLMs for your use case. The process really includes a lot of ask the right question. Think of the movie Matrix when I'm sure everyone's watched that movie, when Neo goes to the Oracle, and the intelligence lies in the question itself, right? So the overall process starts with a very large model, which is then tuned to make it smaller, to create a model that does something really well by following a process of tuning and distilling, etc. So overall, if you look at this diagram, there is potential for a much shorter time to value with the new LLM-based approach. Now, all that is great, but how do I leverage LLMs with FHIR data? I think there may be lots of people like me who just like to ask questions in natural language and skip over the task of creating FHIR search strings, or creating pages and pages long of SQL and FHIR queries. And maybe that's probably true for doctors, researchers, and business analysts also. So maybe a provider would like to ask questions conversationally about their patient. For example, tell me if this patient has been to the ER in the last 2 months. Did this patient have a recent complaint involving chest pains? Now, as a researcher, I might want to find me all patients with a disease D and on a particular medication M. Find me patients with a certain BMI and a sleep disorder. In a way, I want to use LLMs to create my research cohort based on a criteria I can easily express in natural language. Now, as an analyst, I might want to look for metrics. For example, for this hospital, what is the readmittance rate within 30 days? What are the utilization details of doctors in the department? So as you can see, right, there's a lot of personas that might find a lot of value in using natural language to express the task they want to conduct on their FHIR data. Now, in this first approach, now I'm going to go into kind of summarizing the approaches I have in mind for leveraging LLMs with FHIR data. And in this first approach, what I'm doing is I'm throwing the FHIR data to an LLM. Pretty much, I push a FHIR bundle, for example, through a large language model, um, as simply as creating a little prompt, giving it direction, such as maybe ask questions or summarize the FHIR LPR, and along with it, as part of the context, give it the FHIR bundle. So as you can imagine, and I'm going to double click into specific examples and little GIFs that I've got on how I can leverage LLMs. But as you can imagine, with that approach where I use throw FHIR data to an LLM API, the obvious things that come to mind is like, um, is the vendor going to use my data of the FHIR data, patient data to better their model? How about just general InfoSec concerns about sending this PII, PHI data to a vendor's API? While I can't speak to all of the LLM APIs, I can see at least on Google, services once they're GA, they are usually HIPAA compliant or become so in quick succession. Google does not use customer data to better the model, and the methodology Google Cloud has with fine-tuning models includes the concept of an adapter model which stays in the customer project to safeguard customers' IP and data. Since that's out of the way, the second approach that I have, which does not include using FHIR data directly with an LLM API, is leveraging LLMs to generate things like generate the FHIR search string or generate the SQL and FHIR. Because as I mentioned, I think there may be many people like me who don't want to do those tasks. So this approach helps translate the natural language question to a form a FHIR server or SQL analytics server can understand. Needless to say that I think this approach alleviates some of the PII, PHI concerns. Now, I'm going to be running through some examples with some GIFs, and this one is along the lines of approach one. Here I have a little prompt created with a context direction, asking the model to answer questions based on a FHIR. Specifically in this little example, which goes through a loop is, what is the timeline of medical prescriptions? But you can easily envision one asking a whole variety of questions like, when was the last visit to the ER? Or which doctor saw this patient last? This next one is an example of summarization, which I hear is really valuable because it's extremely time consuming for doctors to go through really large LPR records to get a gist of what's been going on with the patient. I just met my brand new provider 2 days ago, and it was a 1.5 hour long discussion to just kind of describe my entire medical history. So here in this example, what I have is a little prompt with the context saying, summarize this FHIR bundle. And notice on the right-hand side, the little knobs to basically let you experiment with the results. Things like temperature, letting you set how much creativity you want the model to have. So ideally, a very low temperature limits the creativity. Top K and top P used for limiting the results based on probability and number of tokens. The token limit being the amount of output you want to see. Now this next example, this little GIF that I have playing is for approach 2. What I have here is a little prompt which is created using a context saying, okay, I want the context says use the FHIR specification and In this approach, I've used something called a few shot approach, in which I, along with the direction, I also give examples of what I examples to the model with saying, this is search expressed in natural language, and this is a search string for the same. And while this is playing, I definitely want to say there's a lot of community efforts going on to generate SQL from natural language using LLMs. So I suspect the SQL on FHIR can piggyback on a lot of that development going on. We're switching gears slightly right now. So with Google's healthcare API, we already are able to ingest FHIR data today. If configured right, this data can be synced in near real time to Google's data warehouse. Remember I mentioned in the beginning that Google is creating an application layer to make it super easy to consume LLMs. What I see coming in the future is the ability to have FHIR data searchable from day one. So imagine all of this data flowing through the healthcare API, landing up in BigQuery, and imagine having a little search engine pointing to a table in BigQuery, and that search engine allows you to ask questions conversationally from the get-go. So think of a world where there's pretty much very little extra work required to be able to conversationally ask questions of data living in your FHIR server. So this is not there, it's not there yet, but it's just something to keep an eye out for. So wrapping up, I think this is just the beginning. Last year, Google released AI-centric products in healthcare, specifically, and there's a whole bunch of products, but I'm going to specifically say, highlight two of them. One was for medical coding to generate medical codes from unstructured data in the form of clinical notes. And the second one was healthcare natural language processing to extract entities with context and relationships from clinical notes. Today, we have generative AI, LLMs to use with FHIR in the context of Vertex AI. We nearly have search abilities out of the box. And I suspect tomorrow we might have PAR models fine-tuned specifically for FHIR. In fact, I think I saw a post recently on LinkedIn where a group has already enabled LLMs on data in EMR environments. So before we open up to QA, special shout out to my partners in crime here at Google. And with that, definitely reach out to me via these methods. My email address is here. I don't have a Twitter handle, but I have my LinkedIn profile. Please feel free to reach out in case of any questions or even conversational chats. With that, love to open it up for Q&A. I'm sure there's plenty of questions. I'm happy to address those right now.
Thank you for your presentation, Ruchika. We will start with the live Q&A. Is there anyone in the room that would like to ask a question? I do have a question in the Whova app. We can go to that question if nobody wants to ask in the room. We have a question on what is the benefit from using FHIR in the generation of FHIR query scenarios? Why not generating SQL queries directly?
Great question. So I think there's definitely room for both, right? So if you're so as you say, right, when you use a FHIR server, that's going to be your transactional server, right? And generally, when you do SQL on FHIR, that's going to be your data analytics, data warehousing activities, use cases environment, right? So I think there's definitely advantages and benefit in having both approaches. One is to kind of offload the task of creating this FHIR search strings, and the second one being, to, as you rightly said, use a SQL natural language to SQL approach to throw those generated queries at your analytics server. So I don't think you would pick one over the other. I think there is room for both.
Thank you. Anyone in the room that has any following up questions on this? Or was the presentation clear? Right.
Hi. A question about what to use this generative AI for. Have you any experience with taking plain text and changing into updates of a FHIR server?
So let me break up the question. First of all, I think anybody who says they have experience in generative AI, in my personal opinion, they're lying because nobody has enough experience in generative AI because it is so new. When it comes to being able to take updates, I think what you're saying is you already have a FHIR bundle and you have a new unstructured source of data, and you want to be able to only pick up the difference between an existing bundle and the unstructured nodes, and just to pick up the differences and possibly pick them up and add them to the FHIR bundle. I think that's what you're asking. I think that's definitely a very valid use case, and I think experimentation needs to be done to see how well it does. But I don't see it. I I I see that as a possible use case someone could use generative AI for. One is there's already a lot of experiments happening to generate one from a clinical unstructured node, generate a file bundle as is. So I know that's been working well for a lot of people. So I think the next step is being able to take all the three pieces, the existing file bundle, clinical node, and the newly created file bundle, and have a multi-phase, kind of having a chain of generative AI prompts to be able to compare the original as well as the generated file bundle. So I think that's definitely on the table to kind of try out and experiment to see how well it does.
Okay, I have a question regarding security. Would you separate the large language model from the data, or how would you deal with FHIR search, which can um, come up with problems when you search for data and get access to data that you're not allowed to access? So when you generate search queries, they can be result in massive data that you are not allowed to access.
I'm so glad you asked this question because that is one of my reservations also. That while it is extremely easy to get to just plug in generative AI, I think there's a lot of tasks around it. So I'll just share my thoughts on this, right? So I think whatever I showed, like that have the GIFs, yes, great. It generates a FHIR search string. But in my opinion, there's two things that have to be done before you can just pick up that string and throw it at, say, your production level FHIR server, right? One is, first of all, check whether the string generated is actually the right string generated for the question asked. And second is whether it returns, whether it does the job that it's supposed to do, right? So one is the validity, whether the string itself is correct and whether the string does what it's supposed to do. So one is more of a specification related correctness, and one is whether the job is being done correctly or not. So in my opinion, there's a couple of different things that need to be done with that generated string. One is, I don't believe you should throw it at the production server. There needs to be a test server in between that is actually that you actually throw the generated string at to check whether it's right. Second thing is, I think there needs to be a lot of RLHF approaches in place, that is reinforced learning with human feedback. And there's a bunch of approaches you can use for this RLHF, that after you get the output from generative AI, pass
Oh, I think. Ruchika, I think you muted or
Ruchika, we can't hear you.
can you hear us?
I just sent her a chat. Looks like she's figuring it out. I'm chatting with her now. We're at time though.
Maybe if people had remaining questions, they could post them in the chat on Whova, and she could, or the Q&A in Whova, and she could come back to them.
Right. Yes. That's also what I wanted to suggest. If you have any other questions left, or your question wasn't completely answered, put them in the Whova app, then Ruchika will be able to come back to them and answer them in the app. Yeah, I would like to thank everyone for their attendance, and yeah, I hope it was a good session for you. I wanted to thank Ruchika, however, she's not present anymore. Nevertheless, let's have a round of applause, and yeah.
Hi, Natalie, are you there?
I'm here.
Okay, we're ready online whenever you are. We've lost a visual of the room though.
Oh,
Oh, there it is. Great, thank you.
perfect. I think it's time to start. 4:10. I see that a lot of people that were here from the previous session are still here. Nevertheless, welcome. I'm Natalie. For the people that didn't see me, I'll be your host. And of course, welcome to all the people that are joining us online. The following presentation will be by Ray, and he will be giving a presentation on the automated detection of potential COVID-19 vaccine adverse events using FHIR notifications. If you have any questions, please leave them at the end. We will have a Q&A session. And for the people online, you will be able to use the Q&A function to ask your questions. The floor is yours, Ray. Go ahead.
Thank you. Hi, I'm Ray Duncan. I don't have a who am I slide, but my clinical background is neonatology. I worked as a faculty neonatologist for about 20 years. But I've also been in software development since I was in college. I wrote programs for clinical lab systems in college and medical school, and I've always had sort of one foot in the IT worlds. For the last 25 years, I've been in full time in IT and working on clinical systems of various sorts. Most recently, I was CTO during the implementation of Epic's EMR at Cedars-Sinai, which was about a 5-year implementation for all the modules. At any rate, now I run a technology R&D team. We do technology scanning and proof of concepts with new technologies. And we work with the companies in our healthcare IT accelerator, who usually have very little experience with integrating with EMRs and clinical systems. So, among other things, we were early adopters of FHIR, and we've been very interested in FHIR from the beginning, from DSTU2 onwards. And I have a marketing slide that marketing makes me put into every presentation. I won't spend any time on this, just to note that we're a health system in the Los Angeles area, mainly in the West Side. The other large health systems in our area are UCLA, Kaiser, Providence, and Ocean. We have one large hospital. Current census is about 1,000, and then several smaller community hospitals, a lot of outpatient sites. So let's talk about the FDA BEST initiative. So the Food and Drug Administration of the United States, everyone thinks of them as just concerning themselves with foods and drugs, but they also are charged with safety of vaccines, blood components, gene therapies, implants, and so on. They have a project called BEST, or Biologics Effectiveness and Safety. They like acronyms at the FDA. Well, they like acronyms in the government. But the BEST initiative is specifically to leverage the national HIE networks to improve their surveillance of the safety of various products and reduce the manual processes and the burden on providers that we currently have. So their vision of this is basically they worked with IBM to build a system that sits in the middle between the national networks and the FDA's internal systems It's called BEST, and it uses the eHealth Exchange, which is one of our national networks in the United States, along with Care Equality, which is the other large one, and Commonwealth, which is somewhat smaller, to use the eHealth Exchange to exchange data with provider organizations and with physician offices. It does use FHIR revision 4. And so I'll just talk a little bit about what happened in the pilot. So currently we report adverse events to the FDA manually. There's an online form, there's a daily report that's generated out of the EMR that goes to pharmacy. Pharmacy reviews the report. They pick out what they think is significant. And they report it to the FDA using an online form, which I'll just show you the top part of here. It's quite a large form. It's a very manual process where a pharmacist basically transcribes information from the EMR daily report into this online form to submit it to the FDA. Then the FDA goes, has to follow up with the sending organization, request the actual chart by fax or by email. And that's a very slow process, as you can imagine. So the FDA, first phase of this FDA pilot, we got involved in this about 2 years ago to start with. The first phase of their FDA pilot was they just left the manual reporting process in place, but they pull the information, instead of requesting it by email or fax or phone call, they pulled it using FHIR resources into their BEST system so they could do case review. So their vision of this is the slide that you can see here. And this was realized at Cedars by the following kind of data flow. So the Epic EMR reporting environment, which is called Clarity, it's an Oracle RAC database on Linux. That generates the data report out of there. Pharmacy reviews that report, as I talked about, and fills out the FHIR's form. But once the FDA gets the VAERS report, they can actually pull the chart immediately, hit our FHIR endpoint for the medications, the vaccines, the problem list, anything else that they want. And you can see here a list of the FHIR resources that are being used by the FDA platform. Most of them they need. There are a few that are kind of optional about the practitioner and the practitioner role mainly. So the second use case of the pilot was detect and report. So here they wanted to really automate the whole end-to-end process by finding the potential adverse effects in the EMR algorithmically, pushing those into the eHealth Exchange. Those go to the BEST system. Then the BEST system can take those patient identifiers and turn around, pull the FHIR resources associated with each patient and put those into the BEST system for clinical review. So that was realized in our environment. So the FDA supplied the algorithms in the form of what they call clinical query language. You can actually find this on the HL7 website, though I have to admit I had never heard of it before. The database wizards on my team translated that to SQL, validated that with the FDA team, and then there's a daily job that runs those queries against the Epic reporting environment, creates a staging table in the enterprise data warehouse, which is separate than the Epic reporting environment. Then the Mirth interface engine picks those up, formats them as FHIR patient resources, puts them in a bundle and pushes those to the AE endpoint, or actually it's an FDA endpoint that they're being pushed via the eHealth Exchange. Then, just as before, the FDA can query our public FHIR endpoint to get the various clinical resources associated with each patient, pull those into their system, and review the cases. There's a semi-automated case review step, which summarizes and screens the adverse events, and then there's a final kind of manual review step by the FDA. So the clinical query language is a kind of a high-level domain-specific language. If you're familiar with Arden syntax for decision support, it's similar in some ways to that. The daily queries just identify candidate patients based on a whole lot of parameters, problem lists, lab values, timing relative to the vaccination itself, and so on. And then that's marshaled into staging tables. So there were, the FDA supplied us with 16 different CQL queries for different conditions. And initially we implemented 4 of them: anaphylaxis, myocarditis, pericarditis, Bell's palsy, and Guillain-Barré syndrome. So you can see here just some little snippets from clinical query language. For the most part, it consists of long lists of codes, which we parsed and loaded into a database table. The code in this clinical query language is kind of high level, very easy to read, and relies heavily upon like small subroutines that process the list of codes. But when you turn this into SQL, it's massive. So it turns basically into hundreds of lines of SQL and there was a lot of back and forth with the FDA to kind of fine tune the results to make sure they were getting what they wanted. The EMR tables are split up. They're basically, after we marshal the data, after we establish the population, then we create some staging tables for population, for diagnosis, for vaccination, medication, and so on. It's easier to query against, and a lot faster to query against those materialized views than querying against the entire database, which is about 4 million patients and millions and millions and millions, hundreds of millions of encounters. So the next step is, once all this stuff gets into a staging table in Enterprise Data Warehouse, Mirth can pick it up and format patient resources into a bundle. So we do hash and timestamp each record so that if there's a subsequent occurrence of an adverse event or a subsequent vaccination and then a new adverse event, we can distinguish that from whatever we might have reported before, but we never want to report something twice to the FDA. So originally we thought about using the FHIR R4 adverse event resources, which, but after joining the Vulkan project and learning more about that, we decided to simply send them a bundle of patient resources with some special tags. And then they could use those patient identifiers to query our public FHIR endpoint. And I'm just going to show you the tags that we added in the patient resource to identify both the vaccination type and the adverse event type. So the pilot experience was interesting. So it really was kind of months of back and forth. We were the first organization to join the pilot, I think, and to get really into a stage where we could work with them on data. There was a lot of back and forth to kind of fine tune this SQL. It would be nice if there was actually a tool to translate CQL to ANSI standard SQL, but there's nothing like that at present. So it was really a very manual process to do that translation. One of the things we ran into early is that a lot of our vaccinations in our EMR are actually for employees and staff and families of staff. And those records often have a break the glass protection on them, and which blocks their retrieval during FHIR. So we overcame that by we had several different attempts to overcome that. And we finally figured out that if we associated the client ID with service account that has privileges to bypass break the glass, that would solve our problem. We did find some other little problems with basically with time frames. And the fact that the FDA really didn't take into account observation and ED patients, which are treated separately from other patients in a separate category from other patients in our EMR.
Great.
So the FDA Business Initiative has been quite successful so far. When we first went to production, we were the only organization in production. That was about a year ago. There's now, that was my alarm. There's now about 12 organizations in production with a total of 28 million patients between them. And there are other organizations, large organizations, that are being onboarded or are working their way through the pipeline. For example, Duke, Providence. Providence is a very large healthcare system in our area, the Mayo Clinic, which everyone has heard of course. So we're hoping that this is really kind of forging a path for automating these processes. The next thing that was a large project team involving 4 organizations. So we have several very, very helpful people from the eHealth Exchange, a couple of scientists from the FDA, and then a large team from IBM, who I think actually built the best system under contract for the FDA. And they've all worked together with us really, really well. The 2 people on my team that have done the bulk of the work are Renee Estiandan, who's really a systems integration wizard and got into FHIR early and is very experienced with FHIR at this point. And Matt Sonneson, who is an expert in databases and queries and reporting environments, and just generally a wonderful guy and can solve any problem. So one of the things that we're working on now that I don't have a slide here for is the FDA is next looking at reporting issues with blood products. And specifically, they're looking to start with positive antibody tests. There's really no good national resource for determining if a patient previously had a positive RBC antibody test. And they want to solve that problem. And the first step is really to get their hands on the data. It is included in the CCDA documents that transit the national networks, but it's buried in a lot of other information. It's pretty hard to extract. So we're looking at a similar data pipeline for reporting positive antibody tests. And I'm hoping that that pilot will start in the next few months. That's all I got. Any questions? Happy to try and answer them.
Thank you, Ray. Thank you for your presentation. We only have 1 minute left. So if anybody has a quick question, then I can hand over the microphone. And otherwise, I would suggest to go to the Whova app to place your questions there. Anyone that has a question? Nope. Okay. Then I would like to thank you, Ray. Please give a round of applause to Ray. And if you have any sessions left after, I hope you enjoy your afternoon.